In the previous video, we have discussed the ellipse whose center is at the origin. Now, we will discuss the ellipse whose center is located at a particular point HK. For ellipse with center at HK, the following characteristics can be derived. The equation of the ellipse whose center is at HK and the major axis is parallel to the x-axis is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Similarly, the equation of the ellipse whose center is at HK and the major axis is parallel to the y-axis is x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals 1. Notice that the quantities a, b, c, and e have the same meaning whether or not the center of the ellipse is at the origin. These are the characteristics of an ellipse whose center is at the origin. The only difference when it comes to ellipse whose center is no longer at the origin is that we now have the value of h and k. So nadagdagan lang ng h at k ang equation, vertices, co-vertices, foci, directrices, or even the endpoints of latus rectum. But still, if the major axis is parallel to the x-axis, the denominator of the x squared term is greater than the denominator of the y squared term. Similarly, if the major axis is parallel to the y-axis, the denominator of the y squared term is greater than the denominator of the x squared term. Ang length ng latus rectum ay ganun pa rin. We have 2b squared over a, mapa-center at the origin or not at the origin. The eccentricity is also equal to c over a, and the length of major axis is also equal to 2a, while the length of the minor axis is 2b. Let us have an examples. For the given ellipse, find the center, principal axis, vertices, co-vertices, foci, length of the major axis and minor axis, eccentricity, and directrices. Number 1, the equation is x minus 3 quantity squared over 25 plus y minus 1 quantity squared over 16 equals 1. In this equation, h is equal to 3, opposite of negative 3, and k is equal to 1, opposite of negative 1. Thus, the center is at 3, 1. For the principal axis, since the denominator of the x squared term is greater than the denominator of the y squared term, the major axis is parallel to the x-axis. If the major axis is parallel to the x-axis, the principal axis is y equals k. Therefore, the principal axis is the line y equals 1. The vertices are h plus and minus a then k. The co-vertices are h, k plus and minus b. The foci, h plus and minus c then k. And the directrices are x equals h plus and minus a squared over c. So for the vertices, we have h plus and minus a, k. We need to solve for the value of a. If a squared is equal to 25, a is equal to 5. Square root of 25 is 5. Therefore, the vertices are h, which is 3, plus and minus a, which is 5, then k, which is equal to 1. Meaning, ang isa i-add at ang isa i-subtract. So 3 plus 5 is 8. Copy 1. And 3 minus 5 is negative 2. Then copy 1. So the vertices are 8, 1, and negative 2, 1. On the other hand, the co-vertices are h, k plus and minus b. First, solve for b. If b squared is equal to 16, b is equal to 4. Square root of 16 is 4. So we have 3, then 1 plus and minus 4. This is equal to 3, 1 plus 4, and 3, 1 minus 4. Simplify, we have 3 then 5, copy 3 and simplify 1 plus 4 which is 5, and 3 negative 3, copy 3 and simplify 1 minus 4 which is negative 3, and these are the co-vertices. While the foci are h plus and minus c then k, to solve for c, we use c squared equals a squared minus b squared. A squared is equal to 25 while b squared is equal to 16. Simplify, 25 minus 16 is 9. Square root of 9 is 3. So c is equal to 3. The foci are 3 plus and minus 3 and 1, which are 3 plus 3, 1, and 3 minus 3, 1. And this is equal to 6, 1. 3 plus 3 is 6, copy 1, and 0, 1. 3 minus 3 is 0, copy 1. And these are the foci. The major axis is equal to 10. 2 times a, which is 5, is 10. While the length of the minor axis is 8. 2 times 4, the value of b, is equal to 8. The eccentricity, c over a, which is equal to 3 over 5, which is equal to 0.6. And the directrices are x equals h plus and minus a squared over c. X ang equation ng directrices since the major axis is parallel to the x-axis. Also remember na kung y ang principal axis, x ang directrix. So this is equal to 3 plus and minus a squared, which is 25, over c, which is 3. Thus, the directrices are x equals 3 plus 25 over 3 and x equals 3 minus 25 over 3. Simplify, 3 times 3 is 9, plus 25 is 34. Then copy the denominator 3. Here, 3 times 3 is 9, minus 25 is negative 16 over 3. So the directrices are 34 over 3, which is approximately equal to 11.3, and negative 16 over 3, which is approximately equal to negative 5.3. To sketch the graph, plot the center 3, 1. Next, the vertices which are at 8, 1 and negative 2, 1. Then the co-vertices 3, 5 and 3, negative 3. Connect these points and this is now the graph of the ellipse. The foci are located at 6, 1 and 0, 1. Remember, the principal axis or focal axis contains the center, the foci, or the vertices. That is why our principal axis is y equals 1. This is the major axis joining the two vertices. And as you can see, the major axis is parallel to the x-axis, while this is the minor axis. Its endpoints are the co-vertices. The directrices are x equals 11.3, which is here, and x equals negative 5.3, which is here. And these are the latus rectum. So this is the graph of the equation x minus 3 quantity squared over 25 plus y minus 1 quantity squared over 16 equals 1. Let us have another example. Number 2, given the equation x plus 2 quantity squared over 36 plus y plus 3 quantity squared over 100 equals 1. Find the center, principal axis, vertices, co-vertices, foci, length of the major and minor axis, eccentricity, and directrices. In this equation, h is equal to negative 2, while k is equal to negative 3. Therefore, the center is at negative 2, negative 3. Since the denominator of the y squared term is greater than the denominator of the x squared term, the principal axis is parallel to the y-axis. And if the major axis is parallel to the y-axis, the equation of principal axis is x equals h. Therefore, the principal axis is x equals -2. The vertices are h, k, plus and minus a. But first, we need to find a. Since a squared is equal to 100, a is equal to 10. Square root of 100 is 10. Thus, the vertices are -2, -3, plus and minus 10, which are -2, -3 plus 10, and -2, -3 minus 10. Copy -2, then -3 plus 10 is +7. Here, we copy -2 and simplify -3 minus 10 is -13. So the vertices are -2, 7, -2, -13. On the other hand, the co-vertices are h plus and minus b, k. But first, find the value of b. B squared is equal to 36, so b is equal to 6. The co-vertices are -2 plus and minus 6, -3. So we have -2 plus 6, -3, and -2 minus 6, -3. Therefore, the co-vertices are 4, -3. -2 plus 6 is 4, copy -3. And -8, -3. -2 minus 6 is -8 and copy -3. While the foci are h, k plus and minus c. To solve for c, we use c squared equals a squared minus b squared, or the square root of a squared minus b squared. A squared is equal to 100, while b squared is equal to 36. 100 minus 36 is 64, and square root of 64 is 8, so c is equal to 8. The foci are -2, -3 plus and minus 8, which are -2, -3 plus 8, and -2, -3 minus 8. These are equal to -2, 5, and -2, -11. Copy -2 and simplify -3 plus 8, which is 5, and -3 minus 8, which is -11. The length of the major axis is 20, while the minor axis is 12. The eccentricity is c over a, which is equal to 8 over 10 or 4 over 5, and this is equal to 0.8. While the directrices are y equals k plus and minus a squared over c, or y equals -3 plus and minus 100 over 8. So we have y equals -3 plus 100 over 8, and y equals -3 minus 100 over 8. Simplify. 8 times -3 is -24, plus, copy 100 over the denominator 8. -24 plus 100 is equal to 76 over 8, or 19 over 2. Divide the numerator and denominator by 4. 76 divided by 4 is 19, and 8 divided by 4 is 2. Here, we have -24 minus 100 over 8. So -24 minus 100 is -124 over 8, which is equal to -31 over 2. We also divide the numerator and denominator by 4. So the directrices are 19 over 2, which is equal to 9.5, and -31 over 2, which is equal to -15.5.